this works now. Yeah, I'm not entirely sure about the audio quality, but we'll see. Okay, so I mentioned these things. Assignment 1 deadline is tonight at midnight, so make sure that your solutions are pushed. And if you have any problems with the repository, then talk to me after the lecture. So I will probably be unavailable from this afternoon, so make sure you have your repository set up before then. Also, in case you're ill, so sometimes you can, if you're ill, then you can get an extension. And in this case, just email me. And then I will give you, if you're ill, you by default, you get a 3-day extension. And just email me, and I will put it into the system that you can deliver late. Okay, and the assignment 2 is out today, and it will all be about bash scripting. And also, that's the topic of the lecture today. So let's start. Bash programming. So before we start with bash programming, I want to give you an overview about the Unix shells that are out there. And the bash is just an example of a Unix shell. So the scripting languages that evolved, that we have nowadays, like Python, like Perl, most of them actually originate from more or less interpreters and operating systems. So when we do scripting nowadays, really it roots from what used to be simple command interpreters that we use in operating system. And the primary example of that is the Unix shell. So if I'm sure you used the Unix shell before. If you have a Mac or if you have a Linux system, then you open up the terminal, then you're faced with the Unix shell. But of course, the Unix shell that we're using today is not the one that, it hasn't always been like this. So the first one, the first major shell was the Bourne shell. It's just called sh. And this command sh is actually still available in a typical Unix system. So you can type in sh and it will open up a Bourne shell. And then from that, more shells evolved. So people came up with extensions like the C shell, the TC shell, that were kind of improvements on top of the Bourne shell. But the one that is used mostly today is the so-called Bourne again shell, which is an improvement by the GNU and the Free Software Foundation on top of the Bourne shell. So that's called, it's the bash shell. And that's what you, basically, whenever you have a Linux system nowadays, there is a bash shell or a derivative of the bash shell installed. So as I mentioned, there's small deviations. There's, for example, the dash shell, which is a lighter version of the bash shell, the corn shell, the set shell. So there are various different flavors of shells that you can work with. But as I mentioned, the bash shell is the one that is really dominating nowadays as a Unix shell. So why should we learn bash? You will see later on, it can be a bit cryptic. It can be, it's maybe not the most beautiful programming environment that you can imagine. But at the same time, learning bash really means kind of learning the starting points of scripting and of Unix. So from that perspective, it really makes sense to start also with bash. Another reason is that it's an environment that is almost everywhere available. So you can, well, on Windows, there's now this Linux subsystem that you can install, and there you will have the bash available. You have it on Mac immediately available. You have it on Linux system immediately available. So it's really something that you can, wherever you are and you want to just quickly automate something, you can just write a simple bash script and be certain, or almost certain, that you will have it available. Another reason is that these shell scripts, they really evolve naturally when you work with programs. So it's very common that Well, when you start attacking a task, the first thing you do is you maybe break it up into a sequence of commands. So maybe you're trying to program a pipeline for image processing, right? So you have to download the image. You have a program. You need to call a program to download the image from the website, for example, from an FTP server. Then you need to rename them, so that's another command. And then there's a final command that maybe converts them to a smaller scale version, for example. So you have this sequence of commands, and you keep typing this in. And so then it's just natural that you put these commands into a file, right? And then already you have a bash script. And then you might want to make it more flexible, so you want to add command line options that you can pass into the script. Then maybe over time you start using this program more and more often, so you introduce variables, if tests, loops, and so on to make it more robust. And then maybe at some point your script is so successful that and you want to add additional processing where bash is maybe not the best option anymore, and then you can move on. And you can re-implement it in Python, or you can re-implement it in another language if you like. So the point here is that it's kind of a natural workflow. Bash is kind of the lowest hanging fruit to get something to work, and then you can work from that and expand it if you need. So that's one thing. And the second thing is that shell scripts are often used to glue together existing programs. So I'll show you some examples later, but that's kind of the Unix philosophy, is that you have every program should do one thing and do it really well, and then you can use the shell to combine these different programs to get what you want. And so the shell is a really good tool to combining or gluing together more advanced scripts. So just to remark, as I mentioned, there's these different shells out there, and you can use the plain Bourne shell if you want. So there's the Bourne shell, right, which was kind of the original one, and there's the bash, which is an extension. You can use both for most of the examples I'm showing today. So you could just use the Bourne shell, but if we use features that are also available in the Bourne shell. But yeah, most of the examples will run in either. So in particular, in Mac, for example, the Bourne shell is just a link to the bash. So if you call /bin//sh, then you're actually just calling the bash shell because they're so similar. And on Ubuntu, the Bourne shell, so there if you call /bin//sh, that's a link to dash, which is almost like bash. It's just a re-implementation that is a bit faster. So you just need to be aware that so most of these things are compatible, and just different operating systems make different choices. And if you're on Windows, then the bash is not immediately available, so there you have to install either Cygwin. You can Google it. It's a package that you need to install. Or if you want, you can install the Linux subsystem in Windows 10. So that gives you a Linux system within your Windows environment. And then with that, you also get bash and Python and everything. So if you want to learn more about the bash, there's loads of information online. So if you Google, I'm sure you'll find everything you need. One first command that is always available on your system immediately is are the manual pages. So there's a command called man for manual. And then as an argument, you can type in, you can provide the name of the command that you're interested in. So for example, if I type in man bash and I execute this, then you get the documentation of the Bourne again shell, right? And so this is a really, really long document file where you can find everything about the Bourne shell. So you might not want to just read this. I don't think it's the best introduction for the Bourne shell, but if you're looking for a specific command line argument, for example, then you can just open up this manual page. And then I just added two links here. which I thought are maybe quite good guides for more advanced bash scripting. Okay, so we need to, it's always good to know when you should use programming language or scripting language and when not. So what are good choices for using bash? Well, the first one is if you have a task that requires a lot of file and directory management. Maybe you want to rename a bunch of files. Maybe you want to delete kind of temporary files and just chunk files that you've got lying around all over your maybe you want to tidy up your PC or whatever. These are good tasks. Then system management. So if you have let's say you have a C program or C++ program and you want to write build script that automatically compiles your program, you can write a bash script for that. Then, as I mentioned that already before, if you have already some scripts available and you just want to combine them in a new way, right? Again, here you can use scripts. And in a way, that's kind of a rapid prototyping task for more advanced scripts. Right? So you start with something just with some bash scripts, and then if it turns out to be successful, you can re-implement it in a more advanced scripting language. And then you can also use bash to do very rudimentary output processing and plotting tasks. The emphasis here is on very simple. So as soon as the plotting becomes too involved, then it's time to switch to something else. And that brings us to the point where bash is not good for. So one issue is cross-platform portability. So for example, if you're doing file management, if you're doing you want to delete certain files or whatever, you have to be aware that Windows treats directories differently than on Linux, for example. So you have the normal slash and the backslash, and so bash doesn't really help you very much to deal with these differences between different platforms. So, for example, Python has much better libraries to program platform portable programs. Then if you're interested in having a script that has graphical outputs or graphical user interface, then bash doesn't really provide you any tools for that. Which also, interfacing with existing libraries, for example, it's not the tool to use for that. Also, as I mentioned before, if you want to do more advanced post-processing or plotting features, then it's much better to switch to Python or another language. And for extensive calculations in mathematics, it's not the best choice. So I'll show you how you can do simple mathematics, but as soon as you hit a limit, then it becomes cumbersome. So here's some explicit common tasks in bash that I often use bash for. So things that you can immediately do is write text to file. You can implement for loops. You can run an application from a bash script. I will show you the so-called pipe principle, where you can feed output from one program to an input to another program. You can write functions in bash. I will show you how to do file globbing and how you can test for certain types, so if statements, and change the behavior depending on which type of file you have. You can copy and rename files. You can create and move directories. And you can remove file and directories. You can traverse through directories. So you can write a program that goes through all the directories and perform certain actions on it. And then you can pack directories. So if maybe you want to send an entire directory with all the files in there over email, then you can just pack everything together, send it off, and unpack it again on a different computer. So here's our first example, the Hello World bash script. It consists of two lines. The first one indicates is an indication on which shell we want to use for that script. So this it's kind of a magic line actually, because normally the dollar, this hash here indicates a comment in a bash script. But if it's on the first line and followed by an exclamation mark, then it tells the bash interpreter that you're calling this with that you want to execute this program with the bin bash shell. Right? So you're basically telling your operating system that this is a script that you want to have called with a bin bash interpreter. We will use the same thing again later on for Python programs. So when we have Python programs, we will use bin Python here, because we will want to indicate to the operating system that we have a Python program. But in this case here, we have a bash script. And then the second line is an actual bash command, so we call echo. So echo writes something out to the standard output, or to the screen. And the text that we want to write out is hello world. So now you have two ways to actually run the script. You could type in this command, in particular the second command here. You can type it directly into your terminal, and then you will see the output. So I can do this here. And not surprisingly, the output here is hello world. The alternative is that you save these two lines as a file. For example, so call it hello world.sh. The sh ending is typically used for indicating that you're working with a shell script. You don't have to. You can call it whatever you want, but it often helps to, just when you go through files to know which type of files these are. So normally I call my shell scripts so that they end with .sh. So you save these two lines as a script, and then you do the following. You have to make the script executable so that you can run it as a program. And the way you do that is with a change mod command. Change mod just changes the file type, and in this case, we add the executable flag to that file. So this line here changes the file type so that it becomes an executable file. And after we've done this, we can call the program by just calling it as any other Unix program. So the / here just indicates that it's a program that is in my current directory, and then here's the name of the program. And if you run this, then you get the same output as above. Okay, so here's a slightly advanced version of our Hello World program. It's almost the same, but now we have two new structure here. We introduced variables. And so you can see we create a variable x that contains the string world, and then when we echo this string, here we insert that variable again. So this is called the variable substitution. So let's look at this a bit more in detail. So obviously if I run this, you get exactly the same output, even though we now started using variables. So creating variables, you just do you don't need to declare them, you can just start using them. So you say x equals 3.4, and after that you created a new variable with the content 3.4. And then later on you can retrieve that variable value again with the $x syntax. Right? So whenever you use a $, you tell bash that now bash afterwards expects a variable name. And then that will be substituted in immediately. So in the example above here, we used the $, and then in this case we use curly brackets, but you can actually also remove them. And so whatever the content of the variable x will be substituted into that string here. So we can also pass variables as command line arguments when running a script. I will show you examples about this later on, but these are called positional parameters. And then if you And then bash comes in with a bunch of built-in commands that you can use immediately. And these you can access with a help command. So if you type in help, then you get all the immediate commands that are available as part of the Born Again shell. And some of them I will explain now to you during the lecture. So really now the power that that we need to learn now is how to kind of combine all these Unix commands that we have to get what we want. So let's have a quiz. So I have two programs here, two little bash programs. Can you tell me what the difference is between the two, or if there's any difference? Yeah?
The spaces?
Okay, so the second one has spaces in the variable definition. So what is the consequence of having spaces?
One is a string and the other is a number.
So you're saying the first one is a,
I'm guessing maybe.
yeah? So you're saying one is a string, maybe the other one is a number?
Yeah.
Mm-hmm. Okay, maybe. Any other ideas? So we can,
The other gives an error.
yeah? So let's see if I can, so I just open up a new script here, a new command. So if I can type in x equals 5 here, and so that works fine. So that was my variable definition, and now I can call the echo command, and then it gives me the 5 as expected. But if I now try to do this, okay, what the bash, so I can try and run this, and it gives me an error. It tells me x, the command is not found. And so what it's trying to do, it thinks you're trying to run a program called x, and then as a first argument, it takes an equal sign, and then as the second argument, it takes the 5. So this is the difference between these positional arguments and a variable declaration. Okay, so if you don't have space, so the important point here is that when you want to declare variables, make sure that you don't have spaces between the equal signs, because otherwise, bash thinks you're trying to call a program that is called x, and then interprets these two things here afterwards as positional arguments. Does that make any sense? Yeah. So yeah, if you're trying to call this, then you just get command not found. Okay, some more words about bash variables. So they're untyped, which means that you don't need to specify which type they are when you start using them. By default, they're treated as character arrays. So just even in this case up here, the 5 is just being a character, even though it could be interpreted as an integer. The consequence is shown here in this example down here. So if I start using this variable x and write x equals $x plus 1, the bash does not interpret this as a numerical or arithmetic operation. Instead, it thinks you're trying to do a concatenation of strings. So essentially, it just says, okay, x is now whatever the content of x was, plus appended with a string plus 1. So the result is, if you print it out, you get the string 5 plus 1. Okay, so just so that you're aware of it. If you really want to do arithmetic operations, then you need to do it explicitly, and you use the let command. So you can say x equals 5, and then you can say let, and then you provide a string x plus equals 1. So this now actually evaluates the arithmetic, this string as an arithmetic expression, and then the output of x will indeed be 6 in this case. By default, types are untyped, but you can explicitly declare the type the variable if you want, which I show you down here. So if you explicitly want to declare a integer, you use the declare command provided with a -i argument and then the name of the variable. So at this point, you have a variable called I that is explicitly an integer. You can do the same thing with arrays, and you can also do the same thing with read-only variables. So this is often helpful if you know that you only want to create a variable once and then never change its content. So you create this variable, and then you declare it as read-only. And then later on, if you want to change it again, then you get an error message saying this is a read-only variable. So the echo command we've already used. So the echo command is used to writing strings out to the standard output. And it takes one argument, so it's the echo command, and then it takes one position argument, which is a string. And in the string, you can use variables. And these variables will be substituted before it actually gets printed out. So there's some variables that are available as magic variables, so we don't actually need to declare them, they're immediately available. The first, and you will find them very often if you read existing scripts, the first ones are the command line arguments. So these, they're called $0, $1, and $2. So these variables contain what the user provided as arguments. $0 is the first argument, and that's actually the name of the script itself. So in principle, you could check what the script name is within the script by accessing this $0 variable. And then the $1 variable is the first position argument. So that's what the user provided after the script name, and so on. So $2 is the second argument, and so on. If you want to access all the command line arguments, you can use this $@ symbol. So this will give you an array, and I will show you to this later on. You can loop over this array. And then you can also check for the number of command line arguments that the user provided. And then the final one is $?, and that tells you this variable contains the status of the lastly executed command. So when you're running something in the bash script and you want to check if that command was successful or not, you can evaluate this $? Variable. And let's have a look how this works. Let's say we want to write a script that takes in a command as an argument and then runs that command and checks if it was successful or not. So an example is down here. So we want to write a script. This script name is run and test.sh. And then whatever comes afterwards is actually a command that I want to execute. So in this case, I want to execute ls hello world /start.cpp. So I want to list all the files that are in the directory hello world and that end with cpp. So I want to run this, but I want to run in such a way that if the command fails, I want to print out a special message. The script is shown above. So the first line here, remember that the $@ symbol was the list of all the command line arguments. So the $@ symbol in this case will contain ls hello world /start.cpp. And by just typing in this variable as one command in bash, bash will actually execute this command. So in this line, I'm executing the command as whatever was typed in its positional arguments here. And then I can add an if statement afterwards where I evaluate this $? Variable. And I check if that variable is 0, then I know the last process was successful, so I can print out the screen, everything went fine. And if that is non-zero, then I know the last command was not successful, so I can print out an error message. So in this case, if I run it, the command is successful, so it actually shows me the files, the CPP files, and then it tells me, okay, this command was successfully executed. Does that make sense? So here's one warning about these if statements. So the syntax between in the if statements, they differ depending on if you're doing integer comparison or string comparison. If you're doing if you know that your variables are both integers on the left and right side of an if statement, then you need to use the -EQ for checking for equality. So in this case, I know my $I is an integer variable and the 10 is an integer variable, so I use this type of if statement. If you're doing string comparison, then you need to use the double equal sign. So in general, it's often clever to because sometimes you don't actually know, because variables are untyped, so you might often not know which type the variable is. So I often end up using the string comparison, and I just wrap the variable as in these quotation marks to make sure that it's a string. So I often use this if statement, and only in very rare cases I actually use an integer comparison. One thing that is often really useful is if you can run a command and store its output as a variable. Let's say you want to create a variable that contains the current date. The way you can do this is, so the idea here is now you want to run a script, the date script, that returns the current date, and then store whatever its output is as a variable, so that you can continue working with it. There are two ways doing that with the same result. So you can use time equals $ bracket and then the command that you want to have executed. Or the second one is to use these special quotation marks here. They result in they have the same result. So after executing this, you will have a new variable called time, and it will contain the output of the command date. So date is a command in Bash. You can call it, and then it will return you this a string. Right? And so your variable would now contain this string here, and you could start working with it. So that's often quite useful. It's another really convenient debugging tool. So the problem is that when you run Bash scripts and they just fail at some point, it's often quite difficult to know why it failed and which line it failed. And to simplify this, you can run the script with a -x, a command line argument. And what that does is, before it executes a line, it prints out that line on the standard output. So the output will be larger and will basically print out the source code and then the result of that command interleaved. And so that way you can immediately see when it crashes, you can just look at the line above and see, okay, it was this source code line that caused the error, and then you just start investigating why something went wrong. So just remember this. So you can either do this when you, in the first line of your file, you can, when you define the interpreter, you just add the -x command argument. Or of course, if you explicitly call the bash command, then you can also use the -x before you provide the script name. So the real power of bash now comes in when we start combining these commands to make a bigger program. And so the reason why this is so important is because Unix provides a lot of commands, but they also only do very, very simple things. Right? So you can use echo to print something to screen. You can use date to get the current date, and so on. So really, if we want to do something useful, we need to be able to combine all these little programs to create something more complex. And in Unix, the typical way on how these processes communicate is always through text. So essentially, our task now is to get the text from one program and move it into the next program as an output, as an input. Right? So the output of one program will be the input for the next program. And then that program's output will be, again, the input for the next program. And so we will use pipes for these. They're so-called pipes. They're just basically connecting two programs, and the output from one goes into the input for the next. So, and these are the so-called pipes, and the pipes in Bash are indicated by a vertical line. And as I mentioned, the pipe sends the output of one command as an input to the next command. So here's a simple example. We have the command ls-l that lists all the files in the current directory in a slightly lengthy format. And then I take this output and pass it to the grep command. The grep command is a filter. With the grep command, you can say, I'm only interested in lines that contain certain keywords. In this case, I'm only interested in the lines that contain the word 3331. And so the result of this will be that you list all the files that contain the words 3331. Yeah. So just from combining now these two, you already have quite a flexible setup. So let's look at maybe some more advanced piping programs. So let's say we are interested in listing the files, but such that they're sorted after their size. So maybe we're running out of disk space, and we want to find the biggest files and just get rid of them. And the way you do that is you list the files again with the ls command. And in this case, I use the -s argument. And by using that, the first column will be, in the first column, it will show me the file size. And so now I have all the files. In the first column, I have the file size. They're still unsorted. But now I can pipe this output to the sort command. And the sort command now sorts all these lines according to the first column. And I use the -r here for -rn for the reverse numerical sort. So I want to do a numerical sort on the first column in reverse order. So the result here is that I will have the files sorted from the largest file first all the way down to the smallest file at the end in my current directory. So we can make this even more complex. So let's say I'm not interested just in the files in the current directory, but I'm also interested in the directory sizes. So maybe I don't have just files in my directory, but I also have directories. And I want to find out which of these directories are the ones that are using up all my space. And for that, I use the du command. Du means disk usage. And it basically lists, it looks at each directory in my current directory and checks how big are all the files in that directory. So here I use that command. So I check all the directory sizes in the subdirectory assignments. Then I sort them in reverse numerical order. And then I pass the result to the less command. The less command just adds pagination so that it doesn't just get printed all in one screen, but I can kind of scroll down and up and down with the keyboard. So in this case, I used two pipes, right? So I first used the disk usage to figure out the largest directories. Then I pass it on to the sort command to sort the outputs, and then I pass that on to the less command to give me some pagination. Okay, maybe shall we have a break? Let's start again at past.
I haven't filled out the web
Er det ikke deg?
Nei, så det er jo jordbrukerland, ja.
Det er din?
Ja,
Ja.
men
Ok, så da er det bare at vente for... Det er det samme.
ok.
Så den er alt klart, men du har
Ja, ok.
ikke
Men
ventet på invitasjon.
det er rart, for jeg fant ikke mailen.
Nei.
Så, men skulle jeg bare gå inn på Git?
Ja, det tror jeg. Hvis du går inn på GitHub, der må jo... Jeg vet faktisk ikke helt, men jeg tror hvis du går til github.com/... Ja,
Ja.
du må finne pending invitations.
Så den har kommet? Det
Ja,
er
bare se på den. Ja. Eller snakke med meg etter forelesningen, kan vi se på den sammen.
Hallo. Jeg tror ikke jeg har fått GitHub invitation, så
Du får den ikke? Skal vi se.
fordi forrige fredag så var det så fullt her, så jeg bare
Hva er programnavnet din? På UiO?
På UiO, Arams, ARAMS. Ja.
Ja, ok. Så det er ikke. Nei, men jeg har det ikke. Er det Aramson?
Ja.
Nei, men jeg har du ikke sett deg på
På kurset?
Ja, men på kurset, men på den Google Docsheet?
Nei, fordi
Har du lest den?
Sign up GitHub, fill out this webform. Jeg har ikke fylt ut webformen,
Nei, det må
men jeg
du
har
gjøre.
en GitHub-bruker. Det har jeg.
Ja. Så det må du gjøre. Det er faktisk ikke viktig.
Men man trenger ikke bruke
Nei,
IO-navnet sitt.
jeg skal fikse det.
Men fordi jeg har også jeg har gjort sånn at jeg linker både IO-brukeren min og den der til den der, så for begge e-mailene mine får beskjed.
Ja, men den viktigste er at du fyller ut den webformen.
Ok.
Ut av den
Men jeg fyller med webformen, så får jeg da invitation og alt
Ja,
det der.
gjør det nå.
Ok.
Gjør det nå, så etter forelesning skal jeg generere representasjon.
Ja,
Ja.
Ja, på den optional påbyggen. Jeg prøvde meg på den. Så jeg har på her så har jeg mappen Git, og så ligger den repositoren
Ja, det
der.
er sant, ja.
Og så har jeg inni Git laget en copy av
Ja.
den.
Ja.
Og så har jeg her, dette er den loggen på begge de nyeste.
Ja.
Så jeg prøvde meg på A og så B, men B ble pushet på begge, eller sånn at jeg hadde nå tatt C og D.
Ok.
Og C, dette er loggen på Git, den er grei.
Mhm.
Men når jeg tar, så hvis jeg tar git push her, så er det up to date. Men hvis jeg gjør det her, så får jeg en feilmelding.
Ja.
Skal vi se. Og så lurte jeg på hvordan får jeg
Ja.
dette bildet der opp, sånn at jeg kan
Så da må du-
redigere.
Så da må du først git pull, faktisk. Fordi nå har du opptatt GitHub, og så prøver du å men med den
Hvis jeg trykker git pull her, så får
Ja.
jeg vel jeg har jo lagret jeg har et dokument der det står change it to, eller der det står det nå.
Ja.
Her står det C. Sånn at, men det blir ikke sånn at hvis jeg tar git pull nå, så forsvinner det dokumentet der. Da får jeg med C.
Nei, det tror jeg ikke.
Ok, så jeg kan ta git pull der.
Men bare lag en kopi av den directory. So Git repository, you can just copy this, just make a backup of it, and
Okay.
then try a git pull and see what happens. And it should result in a merge conflict because you have two conflicting commits here. So you have here change to D and here change to C, and this one you've pushed. This one you haven't pushed, and so now you're basically merging in this change into here, and then that should sit on top. That will sit on top the change to C,
Ja.
and that should, if Git might want might try to fix it automatically, but if the change is conflicting, then it will say, I can't match that, you need to fix it.
And you're saying I need to make a copy of that one?
No, I'm just saying if you want to be able to do this multiple times, do this.
I want to have exactly that
Yeah.
image in the terminal, so
Yeah.
I can.
So I think, can we just try this?
Yeah.
So I just want to make a copy so that you can go back in case. Is it assignment 1? Where we just worked in?
Yeah, and assignment 1 is folder there. So
Yeah. So I just do assignment 1, backup.
sure.
Okay. So now let's try git pull. Okay, so now it tells you, okay, conflict, there's a problem. Automatic merge failed, fix conflicts and then commit the result. So now if you look at, where was the conflict? It was in git conflict.txt. Okay. In assignment, in assignment. Oh, sorry. Sorry, git conflict. So that actually auto merged. Yeah, that's what. What was it before? Sorry. Okay, this is actually quite strange.
I was a little bit unsure on the instruction in the optional task,
Yeah.
where it said to make a copy of the repository. So
Oh, sorry. This
there you
now
have
it is.
it.
I have no idea what. Yeah, I must have done something wrong.
You
Yeah.
can-
So now, see now, this is exactly what Git told me. So Git told us, right? So there was a conflict in this Git conflict file, and it's this line that is affected, and you have these two versions: hello from D and from hello from C. And now it's up to you. You need to now fix this and decide which one.
So this is now the git conflict
Yeah. And you
file.
need to resolve this and add it and commit it.
Okay,
Yeah.
thank you.
Yeah.
Okay, quickly, I haven't received it anywhere. I don't know where the.
Pending invitations. Yeah. So this is maybe maybe you can ask if someone. I think GitHub is actually horrible.
Yeah, it's sometimes. But can you send the invitation once again? Because I think I had a wrong
No,
email.
no, I don't think. No, I don't think so. But
Okay.
yeah, one second. Why don't we try and go there?
Just going there. There's 2 days.
Here we go.
Oh, okay,
So
okay.
can
Perfect.
it actually can I just?
But yeah, it doesn't matter. I have the 4, I have the masters.
That doesn't matter.
Okay.
But can I just take a picture of this?
Oh, sorry. Okay. That's really weird.
Okay, thanks.
Thank you.
right. So, so some of you haven't gotten the GitHub invitation links, and I have to say the GitHub user interface is horrible in that regard. So what we do is we invite you to a team, and then that team has access to your private repository. But the invitation is sent out to an email, and in case that email is in the spam box or whatever, then it just disappears. But if you go to so basically you're invited to a repository and the email notification disappeared. But if you go to the GitHub webpage, there's no kind of notification saying you have been invited to this repo, just join it. So I think that's where some of the confusion came from in that you didn't have access to the repo. So the solution is that you have to, if you want to see your pending invitations, you actually have to go to specifically the organization where you've been invited to. In other words, you have to go to this URL up there, which is github.com/uio-inf3331. So if you go specifically to that web page and you haven't got your repository yet, then there will be kind of a yellow bar here on the top saying you have been invited to join a repository in that organization. Click here to accept that invitation. So, yeah, I hope so for anyone who is still struggling with the repository. I think the trick, and you haven't got the emails, I think the trick is to basically go specifically to that web page, and then you'll see the invitation. It's quite, it's not very user friendly. But yeah, we can also talk about this after the lectures if you're still struggling. Okay, so I actually wanted to show you before we keep going here, I thought it would be nice to teach you every time a little bit about something else. So today, I thought I'd tell you a little bit more about Git. Let me see. So we'll have these tips and tricks. And so I thought today I'll tell you about Git ignore, the tip of the week. Let's see, how does this work? Let's start this again.